All right, guys, so we made it. We're at our last form. We knocked out slope-intercept form. We knocked out standard form. Now we're going to look at the last form, which is point-slope form, okay, which looks a little something like this. Okay, so it's probably easier to look at in the actual problems where you see numbers put into the spots. The trickiest part about point-slope form is this, okay? There's minus signs built into the formula. Okay, now what that means, guys, is this. Negative signs, which are also minuses, okay, also mean the opposite of. So what they're telling us, okay, is whatever number is in this spot and in this spot, we are going to use the opposite of that number. The opposite of that number. So you got to be careful when you're looking at your numbers. Okay, so let me explain to you what that means as far as an actual problem. So if you look at this problem right here, guys, there is a positive 4 in the position of x sub 1, which is going to be our x coordinate. That's the easy part. If it's next to x, it's your x coordinate. But we're not going to use positive 4. We're going to use negative 4 because we take the opposite. The number over here, okay, is the y coordinate because it's next to the y. That's the easy part. You have to take the opposite. So you're not going to use -3. You're going to use +3. So the point on the line is -4 comma +3, which is right there. Okay. If I apply that same exact concept over here to this problem, I got a -1 next to the x. That's my x coordinate, but I'm not using -1. I use +1. I got a +4 next to the y, but I'm not going to use +4. I'm going to use -4. So your point there is 1 comma -4, which would be down there. That's the only confusing part of this formula, right? The number that is in front of the parentheses, if you look at the form, is m. M, we said, represents slope. Remember, we said we're not sure why it's m. You know, why didn't they use s? Well, s would look too much like a 5. So that's our slope. Now, your slope for this one is -2/5. So from the point that you have on your graph, I'm going to go down to 1, 2 over 1, 2, 3, 4, 5. Looks like I can fit another one. 1, 2, 1, 2, 3, 4, 5. So I could fit 2 more points there. So I got 3. Okay, got your line. You're going to label it. And you're golden. Sorry, guys, my marker's acting up again. Okay, over here, I got a slope of 3/7. So from that dot, okay, I might have to go backwards here because I think I'm going to go off from that dot. I'm going to rise 3, run 7. 1, 2, 3. 1, 2, 3, 4, 5, 6. I went off. Okay, so I'm going to go backwards. Instead of rising 3, running 7, I'm actually going to go down 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Okay, so my point is down there. Squeeze that arrow in there, and you got yourself a line. Throw a label on it, and you're good to go. The one thing I just kind of want to hammer home here, guys, with all your forms, okay, all your forms in some way, shape, or form, you're using slope. Whenever you're using and executing slope, you have to have a starting point. I always use the example like this. If you were to receive a phone call, all right, and it was a friend of yours, and they were asking you for directions on how to get somewhere, you know, hey, I need help, I'm lost, how do I get to Jackson Liberty High School? I forget. Okay, you know, if we were in class right now, I'd say, what would be the first question you would ask that person who was looking for directions? Hopefully somebody would raise their hand and say, you know, my question would be, where are you? You know, you can't tell somebody where to go unless you know where they are. So you can't use slope unless you have a starting point. So that's why we put this on the grid first, right here. Okay, that's why we put this on the grid first. Okay, which was down here. Okay,